Hello students, today's agenda is to check homework. We'll be learning inverse of functions. Today, students will be able to find inverse of relations and find inverse of functions algebraically. And before we continue, the inverse of a function is when we have a mirror going through y equals x. So if there is a graph going something like this, the inverse will be something like this. Or if it goes like this, the inverse will go something like that. Okay, whatever is on this side will reflect on this side, and whatever is on this side of this line of reflection will reflect on the other side. And there are different types of relationships. However, some do form functions and some don't. So for something to be a function, you can do a vertical test. The vertical test is that you put something like even your pencil and just go through the graph vertically. And if there is an area where you will touch 2 points, then the graph is not a function. Like in here, only 1 point, but then right here, it touches even maybe 3 points. Like right here, if you align it, that means that that's not a function. For the next one, if you do the vertical test, at every moment, there is only 1 point being touched by that vertical object, either the pencil or a stick, whatever it is. So that makes it a function. It's just that there is not a one-to-one relationship. Why? Because at certain points, if you do a horizontal test, then at certain points there, like for y, when you have -2, let's say, then there are more than 1 point. Still, a function is for every x, you have one value of y. In here, for one value of y, there are 3 different x. Okay, still a function because it passed the vertical test. And for this one, for every single one, you have 1 point. And if you do the horizontal test, still only 1 point, 1 point, 1 point. So that's a function and it's one-to-one. Or it says find the inverse of the relation. In any relation, what you will see is that the inverse will exchange the value of x and y. The positive stays with 5 and the negative stays with 3. The inverse only switches the values for x and y. Okay, that's all it does. So in here we have 5, -3. Now that will become -3, 5. For the next one is 4, -6, so it's -6, 4. For the next one is 9, 8. And for the last one is 5, -3. All I did was to switch x and y. So they gave me points or coordinates for the first relation. For the next one, I'm given a table with the input and output values, okay? And we can represent it the same way with coordinate. So instead of 0 for the input and 3 for the output, we just put 3, 0. So we switch them, get the output first and then the input. The next one is 7, 4, 14, 11, 23, 20. And finally, 25, 22. Okay, in here, this is the input, this is the output, and this same input has 2 outputs. That's when we did the vertical check, and then you had 2 points at the same value for x. Okay, this is going to be -1, 0. I was looking at the next value. So it's -1, -3. For the next one is 0, -3. We have 3, 0, 5, 5, 6, 5, and then 8, 7. It says steps to find the inverse. The first step is to switch f of x for y. After that, you're going to have x and y switch places. The third step is to solve for y now that you switched them. And finally, you're going to change y for the inverse of f of x. That's how you read this. The inverse of f of x. Okay, so this is f of x. This is the inverse of f of x. I'm going to just find the inverse, but then at the end I'm going to graph both the original function and also the inverse of it. I'm going to try to have this in here so that we can follow them. So the first step is to switch f of x for y. So in here, instead of f of x, it's going to be y equals 5x. Then we're going to have x and y switch places. So instead of y equals 5x, we're going to put x equals 5y. Then we're going to solve y, meaning isolated. And so if we're multiplying, the opposite of multiplication is division. And so y is equals to x over 5. Sometimes it's also written as 1/5 of x. And for the second part that we're going to graph it, I think it's better if we have it as 1/5 of x. So the last step is to, now that we solve for y or left y by itself, we're going to switch for the inverse of f of x. So instead of y, we put inverse of f of x equals, and then the solution, again, sometimes it's written as 1, because it's 1x over 5, as 1/5 of x. Just for graphing, that's going to be a lot easier. And so this will be our solution, okay? This is going to be the inverse of that function. Okay, we'll come back to graph these two so that you can see how they look. Okay, for the next one, again, the first step is to switch f of x for y. We switch the places of x and y, switch them. The next step is to solve for y, meaning leave y by itself. So if we're adding 9, the opposite of addition is subtraction. We're subtracting 9. 9 minus 9 is 0, so it cancels. X and -9 are not like terms, so we cannot combine them. We just put x minus 9 equals -3y. The last step is to divide. If we're multiplying, we divide. Remember that in division, we take the sign. This cancels and you get y equals all of that. For the inverse function of x, so we write f -1x, the inverse of the function of x, equals x minus 9 over -3. So if you are not going to graph, this is all you need to do. Okay, you can just leave it like that. But if for graphing, we write it like this. 1 over -3 would be -1/3 x. Negative divided by negative is positive. 9 divided by 3 is 3. Okay, that way we have the initial point and then rise and run. So this is another way of writing it as well. Okay, in here we change or switch f of x for y. So we put y equals x minus 2 over 3. Switch x and y. So x equals y minus 2 over 3. In here, we're going to cancel the division. If we're dividing by 3, the opposite is to multiply by 3. This cancels, and we get 3x equals y minus 2. I'm going to rewrite it in here so I can have more space. So 3x equals y minus 2. The opposite of subtraction is to add 2 to both sides. That cancels, and we get y equals 3x plus 2. The inverse of f of x equals, and then just keep that, 3x plus 2, and that will be my inverse function. And we'll change this so that we can graph it later on. This is multiplication, but first let's switch f of x for y equals 2 times x minus 2. Then we're going to switch x and y, so x equals 2 times y minus 2. As I mentioned, if this is multiplication, the opposite is division. And we get x divided by 2 equals y minus 2. Finally, if I'm subtracting 2, the opposite is to add 2. Since it's crowded, I'm going to do it right here. Plus 2 plus 2. Cancel this, and we get x divided by 2 plus 2. Sorry about that. And on this side, we only have y. Then we substitute the last step to switch it. So inverse of f of x equals, and write this. For the sake of graphing, if you leave it like that and it's not asking for you to graph, then it's okay. But for graphing, you just put as 1/2, right? 1 over 2 multiplied by x is the same thing, plus 2. And so this is my inverse. So for graphing, this is better because you have your rise and your run. And this one for graphing, you are going to have to do the distributive property first. So we're going to start graphing. We don't need to look at the process to get to the inverse because we already did that. So for this one, when it doesn't have a constant in here, it means that you're just adding 0, or that it starts at the initial point, is at the origin. And my rise is 5 and my run will be 1. The rise and run, or slope, always needs to be in fraction form. That's why we put it over 1 for the run. So from the point we go 1, 2, 3, 4, 5, and 1 to the right. 1, 2, 3, 4, 5, and 1 to the right. And we can just draw our line. So that's our first line. The inverse, because it doesn't have a constant, it starts at 0, so right there. And then the slope is, it rises 1 and goes 5 to the right. So this is my sunrise and the run. Okay, so rise over run. Starts at 0, 0, and then it goes 1 up and 5 to the right. 1 up and 1, 2, 3, 4, 5 to the right. And that's my next line. If you notice, the line of reflection should be here. Whatever is on this side reflects on that side, and whatever is in here reflects on that side. For number 2, we're going to graph this one and this one. Again, for the rise and run, we need it as a fraction, so it's -3/1. The initial point is at 9. So I'll cover this, and then I'll go to this one, okay? So the initial point is at 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. And then it goes 3 down and 1 to the right. 1, 2, 3, and 1 to the right. 1, 2, 3, 1 to the right. 1, 2, 3, and 1 to the right. There you go. And then we go to the inverse. Right here, the initial point is at 3. And then this negative goes to only one of them. I prefer to give it to the numerator, but sometimes when I don't have enough space, then that's when I give it to the denominator. So initial point is at 3. 1, 2, 3. And then it goes 1 down and 3 to the right. 1 down, 1, 2, 3. 1 down, 1, 2, 3. 1 down, 1, 2, 3. This is my line of reflection. If you notice, whatever is on one side with the blue line goes to the other on red, and whatever is on this side goes to the other side. Okay, that's my line of reflection. For number 3, that's the first, the given function. This is the inverse we found. This is already set. We just need to put over 1, but for this one we need to fix it so that it can be in y equals mx plus b. So for that one, it's going to be f of x, or y equals. We write this as a fraction, so 1/3 of x, and then negative divided by positive is negative. 2 divided by 3 is not possible, so we just leave it as 2/3. That's my initial point, okay? 2/3. That means that my initial point is a negative 2/3. That means that the first square in the negatives, I'm going to divide by 3, and I get 2 of them. So -1, -2/3. So right there. And then it says that it goes one square up and 3 to the right. Since it's already in the 2/3 right here, I'm going to go around here and then move it 1, 2, 3. So around there. Same thing, thirds. So only one hole will be around there, and then 1, 2, 3. Again for the next one, 1 and 1, 2, 3. So that's my line. Now let's look at the inverse. So the initial point is at 2, and then the rise, this one looks a little better than the other one on top, over the run, which is 1. So the initial point is at 2, and then it goes up 3 and 1 to the right. So the initial point is at 1, 2 right there, and then it goes 1, 2, 3 and 1 to the right. 1, 2, 3 and 1 to the right. 1, 2, 3, and then there's no more space. We graph it, and it goes through here. So something that I want you to notice is that this had 2/3, but then in here it's on x, where it goes -1, -2/3. And cut that into 3 parts, and then it went 1, 2 of those 3 spaces. Okay, so 2/3 in here, 2/3 in here. Okay, right here, -2/3 on x. So if you notice, we put the line here of reflection is at y equals x. And number 4, for this one to be in y equals mx plus b, you have to do distributive property. And so you're going to have, actually with this color, it's going to be f of x equals 2 times x is 2x, 2 times -2 is -4, and then we're just going to put this over 1 for the rise and run. -4 is in my initial point, so 1, 2, 3, 4, and then you go 2 up and 1 to the right. So 1, 2, 1, 1, 2, 1, 1, 2, 1, and then you just draw your line. And for the inverse function, you have 2 as the initial point, so 1, 2 right there, and then you go 1 up and 2 to the right. So 1, 1, 2, 1, 1, 2, 1, 1, 2, and we draw our line. The line of reflection, it's right there. Whatever is on one side, it's on the other side as well, but with different color. And that's how the graphs of inverse of function look. With this, we end our lesson. If you can please give us a thumbs up, subscribe around here. This is a link to the entire unit, and here you will find the next lesson. Now you're able to do your assignment and have fun.